In 511, G&W sold a 20-year bond at par, and that par value is $1,000. Now, 7 years later, the bond is being called in. What that means is there is a option to call the balls in, or it's what's known as a callable bond. And what happens is in the market, rates went up. Rates went down. And so because the rate that G&W is paying on the bond is higher than what they can find in the marketplace, they have an incentive to call that bond in and sell bonds at a lower amount, or essentially refinance. So this bond has a 14% coupon, and the other bit of information that you know is that there's a 9% call premium. What that means is investors are compensated an additional amount when G&W calls those bonds in. So they'll receive their premium back, that $1,000, plus an additional 9% to compensate them for their bonds being called in. Because the alternative is they could have kept their bonds and received that 14% up until the bonds mature an additional 13 years from now. So the cash flows look as such. At time zero, there was a cash outflow of $1,000, and then they received the 14% coupon, or $140 for 7 years. Then at the end of the 7 years, they received the original par value back, plus the 9% call premium for a total of $1,090. So our cash flows are as such: an outflow at time zero of $1,000. In years 1 through 6, actually 1 through 7, there's $140 plus the additional $1,090 for a total of $1,230 in year 7. So there's a couple of different ways we can solve for this. The easiest one is to use the NPV function. So we can type in NPV, and we can use a reference rate, and then we can sum all the cash inflow, or collect all the cash inflows and add back in the cash outflow at time zero. And what we're trying to do then is get this NPV towards a value of 0. So we could do this by gradually increasing the coupon here, or we can just go to the data tab, use what if analysis goal seek, and what we're going to do is change the NPV cell to a value of 0 by changing the rate. And so Excel will optimize this to where it gets it to a value of 0. Okay, and we see that the discount rate is approximately 14.818%. We can also use the IRR function. We just capture all the cash flows. We can guess an amount. We don't need to enter one. And we can see we get the same answer. We'll skip the formula text. Just know this is the IRR, this one's NPV, and we use goal seek. Lastly, we can use the rate function. So equal sign and type in rate to pull up the rate function. Number of periods is year 7. The payment we know is the 140. The present value is the cash outflow of 1,000. The future value is the 1,090. That's that final return of principal plus the premium. The type, it's payments received at the end, and we're not going to guess. So there's 3 ways to solve for this. Again, what we're trying to find is the discount rate for a bond where pay 1,000 at time 0. There's cash inflows or coupon payments of 140 or 14%, and at the end there's the return of principal plus the 9% call premium for a total amount of 1,090. So again, you can use the NPV with goal seek option. You can use IRR, which is probably easiest in this example, or the rate function.